All right, welcome back to the show where we put the building blocks of civilization on trial. And today? Oh, today we've got an absolute heavyweight in the ring. I'm talking about the most consumed man-made material on the entire planet. Second only to water itself, we're talking about concrete. And you know, the source material just nails it with this quote. Think about that for a second. This isn't just some random building material. We're talking about a phenomenon on a planetary scale. It is, quite literally, the rock that we invented to pour our world into place. So how massive are we talking? Well, get ready for this number. We use somewhere between 30 and 40 billion tons of this stuff every single year. I mean, that number is so big it's almost meaningless, right? But what it tells you, without a doubt, is just how dominant concrete is in our world.
Okay, so before we can pass judgment, we gotta know exactly what we're dealing with. What is this stuff really? This material that's just everywhere?
At its heart, concrete is actually a surprisingly simple recipe. It's what we call a composite material. All you do is you take some aggregates, that's just a fancy word for sand and gravel, you add water, and then you mix in the magic ingredient, cement. The cement is like the glue. It reacts with the water, hardens, and binds everything together into one solid, man-made rock. Okay, now this is what I find fascinating. Take a look at the recipe here. The vast majority of it, like 60 to 75%, is just sand and gravel. The cement, the really important part that gives it all its strength, but also, as we'll see, its huge carbon footprint, that's only about 10 to 15% of the mix. That tiny little fraction is doing all the real work. Kind of wild. Now, this stuff didn't just pop into existence. Oh no. It has a long, solid history. It's a story of how it went from being this sort of ancient Roman secret weapon to the global powerhouse that holds up, well, pretty much everything. And this really lays out that journey perfectly. You've got the ancient Romans, right? Around 200 BCE, they figured out how to use volcanic ash to make this incredible concrete. I mean, the Pantheon is still standing because of it. Then, fast forward to 1824, and we get the patent for what we call Portland cement. That's the modern stuff. Then, in the 1900s, someone has the brilliant idea to add steel rebar to it, and boom, skyscrapers are born. And that brings us to today, where the big story is all about innovation. How do we make this stuff greener to keep it relevant? Okay, court is in session. The evidence has been gathered. It is time to present the case. For concrete. What makes it so good? What are the secret weapons that let it take over the world? Well, it turns out concrete has a whole list of superpowers that are just really, really hard to beat. For one, it's incredibly durable. You can pour it into basically any shape you can dream of. It's amazing against fire. It even helps regulate temperatures in buildings. But its killer app, the one thing that just blows everything else out of the water, it's cheap. At the massive scale we use it, nothing else even comes close. But if we had to boil it all down to just one thing, one defining trait, it would be this. Its elite, almost god-tier compressive strength. What that means is concrete is an absolute monster when you try to crush it. You can pile insane amounts of weight on top of it and it just doesn't care. That's why it's the foundation for everything, from massive dams to towering skyscrapers. But, and this is a big but, for all that incredible strength, this chart right here, it tells the other side of the story. Its big, dark secret. Yeah, its compressive strength is off the charts. But now look at its tensile strength. That's its ability to handle being pulled apart. It's pathetic. It's barely 10% of its strength and compression. And that, my friends, is its Achilles heel. And that weakness brings us neatly to the case against concrete. Because every giant has its flaws. And for concrete, well, there are some pretty serious cracks in the foundation, both literally and figuratively. And here it is, Exhibit A, the single most damning piece of evidence. The cement that glues concrete together, its production is responsible for a mind-boggling 7 to 8% of all global CO2 emissions. It comes from two things. First, you need a crazy amount of energy to heat kilns to over 1,400 degrees Celsius. But the bigger problem is the chemistry itself. To make cement, you bake limestone. And when you bake limestone, it just chemically releases enormous amounts of CO2 straight into the air. Let me put it this way. If the cement industry were its own country, it would be the third largest polluter on Earth. That's staggering. And the rap sheet doesn't stop there. We already talked about how it's basically useless when you pull on it, which is why we have to add steel. It's also famous for cracking over time. It eats up a ton of resources. So much so that we're actually seeing sand shortages in some places. And once it's set, good luck trying to recycle it into something useful. It's a real problem. So, we've heard the arguments. The good, the bad, and the ugly. The jury has reached a verdict. The big question is, where does this flawed but, let's be honest, completely essential material actually land on our official ranking? Let's check out the scores. Okay, let's run down the scorecard as of March 2026. Historical impact, we're giving it a 9.5. I mean, from Roman aqueducts to modern megacities, it's undeniable. Mechanical properties gets a solid 8. It's a beast in compression, but yeah, it needs that steel rebar to help it out. Workability, a 9. You can pour this stuff into just about any shape you can imagine. And then look at these two, scalability and cost, and lasting relevance. Both get a massive 9.5. Why? Because absolutely nothing else on the planet can do what concrete does at the scale we need it to. So when you average all that out, you get a score around 9.1 out of 10. And with a score like that, there's really no other choice. Despite its massive, very real problems, concrete is, without a doubt, S tier. So why? Why S tier with all those downsides? Well, this quote really sums it up perfectly. It's the scalable giant. It is the only material that can do what we ask of it at a planetary volume. Think of it this way. If steel gave us the skeleton and wood gave us the warmth, concrete is what filled in all the blanks and gave us the solid ground to stand on. But look, getting an S-tier ranking isn't a get-out-of-jail-free card. You don't get to just ignore your problems. So the real question for this flawed giant is, what's next? How does it evolve? How does it clean up its act? And luckily, there is a path forward. The industry is already working on what you could call a greener pour. It's about things like using blended cements, mixing in stuff like fly ash to cut down on the really bad stuff. It's about using recycled aggregates. It's about developing technology to actually capture the carbon from cement plants. And of course, backing all of this up with smarter, greener building codes. And that leaves us with one final big question to chew on. Is concrete the essential builder that makes our entire modern world possible? Or is it a climate villain that we just can't afford anymore? The honest truth, as we've laid out today, is that it's both. And whether it deserves to keep its S-tier status in the future, well, that depends entirely on whether we can innovate our way out of that contradiction.